Hello, in this video I'm going to take you through the periodic table and how it's arranged for natural chemistry. So the purpose of this video is to show you how the periodic table is arranged and then how from the arrangement of the periodic table you can work out information about elements' chemical and physical properties. Anything with a pen icon in it you probably want to copy down. So here's a lovely periodic table here. So there are over 100 elements. Some of them are man-made, some of the bigger ones, but most of them are naturally occurring. And in the periodic table, the first thing we have that is of use to us is the staircase, which separates the metals and non-metal elements. So you've maybe seen this before. The staircase starts underneath hydrogen. So it starts underneath hydrogen, above lithium and beryllium, and then it steps down from boron all the way down to the bottom of the periodic table. And this line separates the metal and non-metal elements. So on this side, above the staircase and to the right, we've got the non-metals, and then below the staircase on the left, we've got the metals. So as you can see, if I shaded what all the metal elements are, the majority of elements that exist are metals. All of these ones I'm shading in here are metals, and these ones down here are also metals. These ones should fit in these blocks here, but they get removed because it makes the table look a bit easier. And they have slightly different properties to the block that's in the lower block that's in the middle here, which we're going to talk about soon. So that's the first thing. You've got the metals and non-metals being separated by the staircase. So although hydrogen is on the left-hand side, which is where we generally say metals are located, it's a non-metal. You might find some periodic tables where hydrogen is actually placed here, and there are reasons why it could be placed there, which you will learn about in National 5. However, it's mostly placed above group 1, however, it is a non-metal, so don't forget that. So next we're going to talk about groups of the periodic table. So as well as having the two separate sections of metals and non-metal elements, we have groups. And all a group is in the periodic table is a column. So one column in the periodic table, this is called a group. So column is just a group. Now there are 4 groups in the periodic table that you need to learn. And they're all the groups have group numbers and group names. So if we start over here, this drawing straight lines. So this group here is group 1. So group 1 is called group 1 because it's the first column in the periodic table. As well as having a group number, this group has a group name. So this group are called the alkali metals. And we're going to talk more about them in a minute once we go through the rest of them. Okay, the next group we're going to look at is, we'll change the colour. I like colour coding things. Is this group here. So although this has a number 17 on the top of it, up here, you can see that 17. This is actually known as group 7 because we don't count these groups here as numbers. Okay, so these columns don't get counted as numbers. So the groups go 1, 2, 3, 4, 5, 6, 7. And then this is group 8, but it can also be called group 0. We'll talk about that in a minute. So group 7 are called the halogens. Okay, and again, we're going to talk about their chemical properties shortly. And then the last column we have is sometimes called group 8, sometimes it's called group 0 numerically. So it's called group 0 because these elements in this group make 0 bonds to any other atom, so they don't make any bonds at all, which is why they're sometimes called group 0. But the group name, the number being 8 or 0, the group name is noble gases. Okay, so group 0 are known as noble gases. The last group that we're going to look at doesn't have a number, it only has a name, and it's this group here, this lower block. And this group is known as the transition metals. Okay, don't worry about copying this down because I've got it summarised on the next slide. However, what you might want to do is if you've got a periodic table, either in your data booklet or you can print one out, you might want to colour code it with some highlighters and write this information on to your periodic table just so you can picture it. If you are more of a visual learner, you like to see things in pictures, and this is a good way to help you learn the groups of the periodic table. Okay, so if we move on. So this is the wee summary of the groups which you can copy down in the table format. So we've got group number 1, which are known as alkali metals, group 7, which are the halogens, 8 or 0, which are the noble gases, and then we've got the middle block, which don't have a number, that are known as the transition metals. So if we look, have a wee talk about their chemical and physical properties now. So the alkali metals, now hydrogen is not really included in this, so we really are, when we're talking about the alkali metals, we really talk about lithium down to francium. So they are all solid metals, well, most of them are solid metals. The last couple can be liquid at room temperature, depending on the temperature of your room. But they are good conductors, so all metal elements are good conductors of heat and electricity. And the alkali metals are extremely reactive with water, so we'll put a link to it in the video description for you to have a look at this. You can also type into Google Raynac alkali metals video, so you can see that, and that'll show you how reactive they are. Then group 7, halogens, so they're all non-metal elements, and they come in, some of them are gases, some are liquid, and some are solid. So the one that's a liquid at room temperature is bromine, iodine is a solid at room temperature, and fluorine and fluorine are gases at room temperature. But they are very reactive non-metal elements. The noble gases, which is the last column, group 0 or group 8, they are all non-metals and they are extremely unreactive. They don't react with anything, hence they don't form any bonds, which is why they can also be called group 0. The reason that they don't react with anything is because they have what we call stable electron arrangement. So you look at that more when you look at atomic structure. But if an atom has a stable electron arrangement, then it won't react with anything, because the only reason atoms react is to maintain, gain stability. Sorry about the dogs. So then we've got the noble gases, which are non-metal gases, so they're the last column, and they are totally unreactive, so they don't form any bonds with any other atoms, which is why they get called group 0. The reason they don't react is because they have stable electron arrangements, so you'll learn more about the electron arrangements when you look at atomic structure. But basically, atoms will only react in order to obtain a stable electron arrangement. So if they've already got a stable arrangement, then they won't react with anything, which is the case with noble gases. And then the last thing, we've got the middle block, the transition metals. So they're mostly all solid metals, with the exception of mercury, which is a liquid at room temperature. And they have lots of different uses in society. So if you look at the transition metals, you'll probably see some of them, and you'll learn more about this in Unit 3 of the National Core course. But for example, gold and silver, they get used in jewellery a lot. Iron's quite often used in building structures, statues, etc. So there's a few there that you might recognise, but they've all got slightly different uses. So now we're going to look at other information that we can get from the periodic table about a specific element. So every single element in the periodic table has their own symbol and their own number. So if we take hydrogen, for example, so hydrogen has the symbol H and it's got this number at the top called it's number 1. So this number is known as its atomic number. And the atomic number is specific to every individual element. So every different element has its own atomic number. So if we take then helium, for example, that's got the atomic number 2. Arsenic has atomic number 33. So every element can be identified by its atomic number because that's special to it. You can also identify them by their symbols because every element has its own symbol. So you'll notice hydrogen and helium both start with, their names both start with H, but they have 2 different symbols. A symbol will only ever consist of a maximum of 2 letters, and the second letter, if there is one, is always lowercase. So you should never write an element symbol that has 2 capital letters. So for example, if you were writing calcium, it should not be written as Ca. It should be a capital letter and a lowercase letter. We flip to the next slide. Okay, so this kind of summarises what we talked about in the last slide. So all elements, you can identify them by their symbol and their atomic number. And this little bit of information here is useful when it comes to the structure of the atom. So the atomic number of an element is equal to the number of protons in its atoms. So that means that if an element has atomic number 15, then it's got 15 protons in its atoms. If it's got atomic number 22, then it'll have 22 protons. So if we look at filling out this little table down here, the symbol for hydrogen is H, and you can always look it up in the periodic table or in your data booklet. You don't have to remember them off by heart. And the atomic number assigned to hydrogen is 1. This means that it will also have 1 proton. Potassium, that symbol is K. Now, you might have thought it was P, but you should never assume because some of the elements have their names given to them from their Latin and Greek names, which were the languages that were more widely spoken when they were discovered. So never assume you know the element symbol from its first letter. Always check it just to be safe. And the atomic number for potassium is 19, which means it also has 19 protons. Lead is another one. You may think the symbol is L or Le, but it's not. Actually Pb, which you may say is nothing like lead, but it's because the Greek name for lead is plumbum, or it could be the Latin one. Yes, plumbum is lead's official name. And that's atomic number 82. You may find it takes a while to find the elements in some cases. You just have to keep looking, snake down the periodic table till you find it. And that means it also has 82 protons. Okay. So, if we go on to the next slide, I've got some for you to try here, and I've also added in this last column, which is asking you what group it's in. So look at what column it is in the periodic table and write down the name of the group that it falls into. So if it's placed in the first column, group 1, it would be in the alkali metals. If it's in the 7th column, group 7, it would be in the halogens, etc. Down the bottom, I've also added in different information, so you've got to try and work out from the symbol what the name is, and then atomic number, etc. Okay, so you can pause the video and try this yourself. But by the end of this, hopefully, you are now able to name the 4 main groups in the periodic table. You can identify an element symbol by looking it up in the periodic table. You can also then identify what an element's atomic number is. And you can, from the atomic number, tell me how many protons are in the atom of an element. Okay. On the next slide, I'm going to put the answers to the table that was just shown to you before, so you can check all of your answers. Okay, so I hope that was helpful. Thank you.